Hey, what's up, Chem peeps? Let's get into some excess and limiting using ice tables. How many moles of excess reactant remain when 60.0 milliliters of 1.0 molar hydrochloric acid, HCl, react with 25.0 milliliters of 0.80 molar barium hydroxide? Whew, doozy. With any stoic problem, let's first write a balanced chemical equation. Boom. Our next step is to set up our ice table here. Remember, we're always going to use number of moles when it comes to excess and limiting reactants. I'm going to determine the number of moles of hydrochloric acid using my molarity equation. I've got a 1 molar solution and I've got 60 mils or 0.0600 liters. I'm going to multiply those two things together to get 0.060 moles HCl. I'm going to throw that up into my ice table. Next, I'm going to figure out moles of barium hydroxide, again using the molarity equation. I've got a 0.80 molar solution, and I've got 25 mils or 0.0250 liters. A little trickier here when it comes to doing this without a calculator. So I'm going to throw it into scientific notation to get 8.0 times 10 to the minus 1 is equal to x over 2.5 times 10 to the minus 2. When I multiply these two things together, right, I end up with 20 times 10 to the minus 3 moles, which isn't correct notation. So I'm going to convert that by moving my decimal over 1 to 2.0 times 10 to the minus 2 moles, or in standard notation, 0.020 moles of my barium hydroxide. Boom. I'm going to throw that up into my ice table. All right, initially I don't have any product, and then I've got to choose one of my reactants to be limiting. The way that I do it is I look at my initial number of moles, divide by the coefficient. Whichever number is smaller is limiting. So 0.06 divided by 2 is 0.03. 0.02 divided by 1 is 0.02. Clues me into this is being the limiting reactant. If it's limiting, it gets completely used up. So I'm going to decrease by 0.020. This is going to decrease by twice that amount. Again, take note of the coefficient. So this is going to decrease by 0.040. This is going to increase, take note of the coefficients, by 0.020, and this will increase by 0.040. Again, note the coefficients 2, 1, 1, 2 match the ratio of 0.04, 0.02, 0.02, and 0.04. So at the end, I'm going to have 0.020 moles of hydrochloric acid left over, no barium hydroxide. I'm going to have 0.020 moles of barium chloride made and 0.040 moles of water. The question is asking us about the excess reactant. In this case, the excess reactant is going to be the HCl, and there's going to be 0.020 moles in excess. Ice tables. Boom.